Okay, for this video on 8.5, this is a bit messier than I wanted it to be. We're going to bounce back and forth between two smart files right here, but I think we'll get the point across. What we're working on in 8.5 now, guys, is adding and subtracting rational expressions. And I just want to remind everybody that what we're doing here in Chapter 8, we're dealing with rational numbers and rational expressions. And rational really just means that we are dealing with fractions. So when we're talking about adding and subtracting rational expressions, we basically need to go back to, I don't know, 5th or 6th grade math and talk about how to add or subtract regular fractions first. Then as we progress, we'll start throwing some variables into the mix and look at some more complicated problems a little bit along the way. But let's go back to the way that I'm hoping anyway this was explained to you guys years and years and years ago. So the big idea here is that if you're going to add or subtract two fractions, you need to come up with a common denominator. And to kind of illustrate that, let's take a look at what we've got here. 5/8 plus 1/4. And what I have off to the right here is a circle that's cut up into 8 pieces. So let's think about that as a pizza, everybody. Usually with a moderate-sized pizza, like a medium or something, you might get 8 slices there. So let's say that you are really, really hungry, and you're going to eat 5 out of those 8 slices of pizza. So you're going to eat 1 and 2 and 3 and 4 and 5. Okay, so that's more than half the pizza, must be a pretty small one, that you ate yourself. Your friend, though, ate 1/4 of the pizza. So obviously they couldn't eat the pieces that you did right there. Now that 1/4 right there, if we were to think about if this same pizza had been cut only up into fourths rather than into eighths, then what your friend would have eaten is 1 out of those 4 red, really the word is quadrants. So your friend would have eaten this much right here. What I just shaded in red represents 1/4 of the pizza. So in total now, the question here is how much did you and your friend eat together? Well, if we look at the original 8 slices of the pizza, how many of them are shaded, meaning that they were eaten? Looks like a grand total of 7. So you and your friend together ate 7/8 of the pizza, leaving just this 1/8 of a slice right here that wasn't eaten. Now, the way we did this back in the day here is you would have looked at your denominators, 8 and 4, and tried to come up with what's called the LCM, the smallest number that 4 and 8 both go into. So that stands for least common multiple. And the smallest number that 4 and 8 both go into is 8. Now, there are complicated ways mathematically of determining what that LCM is. It has something to do with finding the prime factorization of each denominator, which in this case is 2 to the third, and then 4 is 2 to the second, and then taking all of the factors, and the only factor we have here is 2, and taking it to the highest power, so that 2 cubed of 8. But I'm honestly hoping that at this level, you guys have developed enough of a number sense that we can kind of eyeball what the LCM is. Anyway, if that common multiple is, least common denominator or multiple is 8, this denominator is already okay. It doesn't need any work. But the second denominator, 4, is going to need to get multiplied by a 2 in order to turn into this 8 right here. And if you're going to multiply the bottom of your fraction by 2, you have to do the exact same thing on top. So the first fraction stays the way it was, 5/8. But the second fraction now, you'd multiply the 1 times the 2 in the numerator to get 2, the 4 times the 2 in the denominator to get 8, and now you have the common denominator that we need in order to add these two fractions together. 5/8 plus 2/8 is going to get us our answer of 7/8. So of course we got the same answer whether we kind of did this one graphically or whether we did it numerically, but you're not going to have the time or really the ability to draw a picture for every one of these adding problems that we're going to do. So hopefully that refreshes your memory a little bit on how you find a common denominator and then add those two fractions together. And I guess I should be consistent here, guys. We were writing down some key concepts right here back in section 8.4. So let's go ahead and write down the key concept, I guess just one of them there, okay? The key concept for adding two fractions. A over B can be added to another fraction, which would be C, but that needs to be over B as well. You've got to have a common denominator. And when you do that, you find your new numerator simply by adding the two numerators together, A plus C. But the denominator stays the same. So it's a plus c over b, and that right there, you guys, is the key concept for how we would add fractions. And it's actually the same if you're going to subtract fractions. So if I make that a plus or minus, this is still valid then for how to subtract fractions as well. So we've got to get a common denominator first, then you simply add your numerators or subtract them, and you keep the common denominator the same. All right, so let's see that in action here, guys, on a problem like this. So now as we start seeing not just numerical fractions, but what we call rational expressions, these are fractions that have variables in there as well, the concepts are going to be exactly the same. So what's happening here? 3n plus 1 over 2 plus 7n minus 5 over 2. This is a relatively straightforward problem, guys, because you've already been given a common denominator among these two fractions. So this is exactly what you want to see, and your eyes should light up here, everybody, because all the hard work has been done for you. So what are we going to do? We're going to add our two numerators together. 3n plus 1 is going to get added to 7n minus 5. And how do we add two algebraic expressions? We combine like terms. The 3n is going to get combined with the 7n to make 10n, and then a positive 1 gets added to a negative 5, and that's going to get us a minus 4. And the denominator stays the same. So we end up with 10n minus 4 over 2. And in some problems, you can quit right here and you'll be done, but not in this one. One thing you always need to think about doing, if it's possible, is simplifying your fraction the way that we did back in section 8.4 by factoring and canceling. And the numerator, it's not much, guys, but there is a common factor there from 10n and 4 of 2. So we're going to divide that out with factoring here, and that's going to leave us with a 5n minus 2 all over 2. And now what happens? We have an identical factor, top and bottom. They cancel each other out, and our answer is simply 5n minus 2. You could put a 1 down here on the bottom because this 2 divided by 2 is 1, but that's not necessary, and in fact doesn't really serve any purpose. So the best way to write our answer is just 5n minus 2. All right, that was that example right there. Hopefully not too bad. Okay, here's another one that's, again, a relatively simple problem. Why? Because the denominators are already the same. The difference here in number 3 compared to what we just did in number 2, we're now dealing with subtraction. So what we really need to think about doing here, guys, is taking that minus sign and distributing it into that second fraction's numerator. So we can go ahead and dive right in because the denominators are already the same. We've got a 13x, and now this is a minus 4x right there. 13x minus 4x is going to leave us with a 9x. And now this gets a little tricky. We have a positive 11 right here minus negative 7. So distributing that minus to the negative 7 actually makes it a plus. So it's 11 plus 7, and we end up with a plus 18 all over 15. Now again, in some problems you might be done. Like for example, if this came out to be a 17, there's no factoring that could be done here, and there's no canceling that can be done. But as it were, we can pull something out in that numerator. 9x and 18 have a common factor of 9. So we'll divide that out and be left with an x plus 2 all over 15. Now, in the last problem, we had a 2 here and a 2 here, identical factors, and they canceled each other out completely. Now, that doesn't happen here, but 9 and 15 do have a common factor within them. That common factor is 3. So we're going to divide that 3 out from both of those numbers. The 9 in the numerator divided by 3 is going to leave us with a 3, and then an x plus 2 after it in parentheses. And in the denominator, the 15 gets divided by 3, and we end up with a 5. And there's nothing else you can do to simplify that, so that is your final answer in this one here. We know we're done because we've done all the factoring we could do, and we've done all the canceling that we could do. Okay? And so that's all we can do then on that problem. All right, it's time to step it up a little bit here, guys. The plot now thickens. We're going to add two rational expressions here in example number 4, but they don't have a common denominator already. So what's really challenging about this section, if it seems easy so far, I hope it does, but what makes this problem hard is trying to build your LCM, or by the way, if you use the phrase LCD for lowest common denominator, those really mean the same thing. We need the smallest number that each of these denominators will go into. So 4 and 3, again, I'm hoping you guys can think not very hard about this one and tell me the smallest number they both go into is 12. One little hint that I want to give you guys is if you're ever not sure, you can always just multiply these two denominators together, and that'll get you a common denominator. Not necessarily the lowest common denominator, but it'll always get you something that will work, and you can kind of work then later to reduce and simplify your answer a little bit more. So if you're ever stuck, just multiply those two together. Now in this case, their product, 12, is the least common denominator. So we're good with this one as it is. Now, here's where things get interesting. We need to take both of these two fractions and change them so that they have this denominator here of 12. So the first fraction is going to get multiplied by something that'll turn the denominator into 12. So you're going to look right here and say, okay, 4 times what will give me 12? And the answer to that is 3. So you're going to put a 3 on the bottom, and then you have to put a 3 on the top as well. And the reason for that is because the numerical value of 3 over 3, anything divided by itself other than 0, is 1. So you're taking this original fraction here, 2a minus 5 over 4, and you're really just multiplying it by 1. Now that'll change the format of the fraction, but it won't change the value of the fraction, and that's the really important part here. We have to do the same thing on the second fraction now. Let's take a look at its denominator, which is 3. What do we have to multiply by 3 to make it become 12? This one needs a factor of 4. And we have to then put the exact same number on top, 4, so that the value of 4 over 4 is 1, and we're not changing the value of this second fraction. Okay, so now it's time to convert here, everybody. We're going to take this 3 and distribute it into the 2a minus 5. So let me put an equal sign here, and here we go. 3 times 2a is going to be a 6a, and a 3 times minus 5 is a minus 15. And in the denominator, 3 times 4, there's our common denominator of 12, plus second fraction now, I'm kind of backwards distributing that 4, but the monomial goes into the binomial regardless of what order they're in. 4 times 6a is going to be a 24a, and then 4 times 1 is going to be a plus 4, and in the denominator, 3 times 4 is 12 again. And now, this problem looks a lot like the last ones that we did, where we were given two fractions already with a common denominator. So we just pick up right where we left off there. We're going to add these two numerators together. 6a plus 24a is going to give us a 30a. And then a negative 15 plus 4 is a minus 11. That's interesting. All over, we keep the common denominator the same of 12. And in the last two problems, when we've gotten to this point, we've had to factor and cancel. So we should definitely think about that right now. But unfortunately, maybe fortunately, there is no common factor that we can divide out from the 30a and the 11 up there on the top. And with no factoring, you can't do any canceling. This is our final answer here, guys. That is as good as it is going to get. 30a minus 11 all over 12. Now, just for the sake of argument, if instead of 11 this was a 10, then yeah, we could divide out a 2 in the numerator and get what? A 15a minus 5 all over 12, and then divide out the 2's right here, a 1 and a 6, and then you'd end up with a 15a minus 5 all over 6. That would be your answer then. So just want to warn you guys that certainly can happen, but the way that this problem worked out, couldn't factor anything, so you can't cancel anything. Okay, so that's how you would add two fractions here that have unlike denominators. You need to get their common denominator. And let's look at this guy right over here. The plot, actually this one, Okay, I know why I wanted to do this problem with you here. Yeah, so let's take a look at this guy right here. We've got a 4y minus 21 all over y plus 3, and then plus a 2y plus 39 all over y plus 3 as well. And at first glance, this problem looks easier than the one we just did. In fact, it probably is. Why? Because the two fractions that we're adding already have a common denominator. So we need more practice at finding that, but we're not going to get it on this problem. But I do remember what happens at the end here. Okay, we have a common denominator. Let's go ahead and add our numerators. 4y plus 2y is going to give us a 6y here. And then we have constants, a negative 21 and a positive 39. So that's going to be a plus 18 all over a y plus 3. And in some cases, you'd be done right here, but you always need to ask yourself, can I factor anything? And if so, can I cancel there as well? Well, in this one, I'm hoping you guys see it. Up in the numerator, we can pull out a GCF of 6, and that's going to leave us with a y plus 3. You can't do any factoring in the denominator. It's just y plus 3. And now we want to check to see, are there any common factors here that we can cancel out from both the top and the bottom? And I'm hoping we see this one. The entire factor of y plus 3 cancels out on both the top and the bottom, leaving us with an answer of 6. Now, the significance of that, everybody, is if we were to go back to the original expression right up here, if you were to put in any value in the world for y other than negative 3, I'll explain that in just a second, but y cannot equal negative 3. If you were to put in any other value for y into the original expression, your answer is going to end up equaling 6. Let me just show you that real quick right here. If I were to put in something simple like y equals 2, let's see what happens here. 4 times 8, 2 is 8. 8 minus 21 is a negative 13 over 2 plus 3 is a 5, okay? And then plus, again, y is 2. 2 times 2 is 4. 4 plus 39 is 43. And then in the denominator, 2 plus 3 is 5. Add them together, negative 13 plus 43, we end up with 30 over 5. And sure enough, 30 divided by 5 is 6. So that will work for any y value that you choose, including positives, negatives, fractions, decimals, anything except for negative 3. And the reason for that is if you look at what happens in the denominator, if we let y equal negative 3, your denominators are both going to become 0. And that's the one denominator that we can't have. So you kind of have to exclude that value right there from the domain of this function. But if you were to put in any other y value other than negative 3, you're going to get 6 for your result. All right, guys, I'm going to save that real quick right here, if you can just humor me for a second. And then what we're going to do is go back and we are going to, sorry about that. All right, open up another file that I have that has some other good stuff that I want to go through with you as well here. So I think this is going to help you a little bit more on your homework than what we had before. So this is kind of an older file that I have going right here. So I'm going to switch a few things around. And I think we're going to skip this first part right here. And we're going to work on finding the least common multiple as we're going through. But let's get into this problem right over here. This is similar to what you guys are going to see on your homework here in 8.5. So adding and subtracting fractions, and here we go. 5 over x minus 3 plus 9 over x plus 2. First thing I want you to notice, this is not as nice of a problem as some of the other ones we just saw. The denominators are not the same right now. So that's really what I wanted to work on in the second part of these notes. How do we find that common denominator when it's difficult to come up with right there, okay? So what are we going to do now? What we normally would do is try to factor our denominators. That'll help us build the least common multiple, but neither of these two denominators factors. X minus 3 and x plus 2, there's nothing you can do to clean those up and make them better. So what that means, everybody, let's switch colors to green right here. Okay, this is actually kind of a good thing. When the denominators don't have anything in common, your least common multiple starts with the entire first denominator, which is just x minus 3. Let's put parentheses around that. And then we multiply that by any factor in the second denominator that we don't already have in the first. Well, x minus 3 was the only factor from the first denominator. X plus 2 is the only factor of the second denominator. Do we already have an x plus 2 here? No, we don't. So we have to tack on an x plus 2, and that is your least common multiple. In an example we did in the previous file, if you guys remember, it was something over 3 plus something over 4. I told you guys that you can always just multiply those two denominators together to get a common denominator. That's exactly what we've done right here. We've multiplied x minus 3 times x plus 2, and you don't even have to FOIL this out. Now what we need to do is multiply each of these fractions by something that'll make their denominators become this LCM. So take a look at your least common multiple right here. It's got two factors, x minus 3 times x plus 2. And ask yourself, what's missing from this denominator right here to make it turn into this? Well, it's missing a factor of x plus 2. And we've got to do the exact same thing in the numerator that we did in the denominator. So we multiply the first fraction by x plus 2 over x plus 2. Now on to the second fraction. Look at its denominator, which is x plus 2, and ask yourself, what's missing to help it become this? Well, it's missing a factor of x minus 3. So we're going to multiply x minus 3 on both the top and the bottom of that fraction. All right, now it's time to start converting these. So here we go. The first fraction, I'm going to backwards distribute the 5 into the x plus 2 there. So 5 times x is going to be a 5x, and 5 times 2 is a plus 10. All over, good news here, guys, you do not need to FOIL this out. We're going to leave it in factored form of x plus 2 times x minus 3. The rule I want you guys to follow right here, everybody, is that we have to expand your numerators. That's why I distributed the 5 and got 5x plus 10. But you never need to expand your denominators. You can leave the bottom in factored form. Okay, and then plus, let's move on to the second fraction now. We're going to distribute that 9 here. We're expanding the numerators to get a 9x minus 27, but again, we leave the denominator in factored form. So that one is going to be just an x plus 2 in parentheses times an x minus 3 in parentheses. And now we have the common denominator that we needed. Let's go ahead and add those numerators together. The 5x plus the 9x is going to give us a 14x. And then a plus 10 and a minus 27 is a minus 17, and the denominator stays the same. X plus 2 times x minus 3. Now, in some problems, this is when you're done. In other problems, you have to try to factor and then cancel. So we always need to think, is there something I can do to factor this? Well, there's nothing that we can factor out from the numerator. 14 and 17 don't have any common factors other than 1. And if there's no factoring that you can do, there's no canceling that you can do. This is our final answer here, guys, for this problem. Okay? So that's the way we handle a problem here, where we're adding two fractions, two rational expressions that don't already have a common denominator. Let's look at another example like this one. All right, and the plot thickens a little bit here for two reasons. Number one, hopefully you'll see right away, this is a subtraction problem, not an addition problem. That makes it a little bit harder, but the more interesting change here is that there's more going on in our denominators right here than we had before. Both of those denominators can be factored. So what I'm going to do, guys, I'm going to get a little bit lazy right here. I'm just going to cross out these denominators, and I'm going to factor them directly underneath where they're written right now. So I'm hoping you guys are looking at this going, oh yeah, I know what to do with both of these. X squared plus 8x plus 15, that's a quadratic trinomial. It factors into, most likely, the product of two binomials. The x squared breaks up into x and x. The signs are going to be the same and both positive, so plus, plus. And we need two numbers to multiply to 15 and add up to 8. That's going to be a 5 and a 3. So, okay, I factored that denominator, and that's where we are right now. The second fraction, its denominator, we got to get good with this phrase, everybody, is a difference of squares. It's going to factor again into the product of two binomials. The x squared becomes x and x. Anytime you're factoring a difference of squares, the signs are 1 plus and 1 minus, and then the square root of 9 is 3. That goes here and here. So the x squared minus 9 factors into x plus 3 times x minus 3. So now that we've factored the denominators, now it's time to build your lowest common denominator or least common multiple. I probably should be using LCD a little bit more. So here we go. Now I'm going to try to say the same thing I said here on the last problem. To build your lowest common denominator, you start with every single factor from the first denominator. So the first denominator is right here. I just write it in its entirety. X plus 5 multiplied by x plus 3. Then you go to the second denominator, which is right here, and you now write every single factor of the second denominator that isn't there already in green. Do we already have an x plus 3 in our lowest common denominator? Yeah, we've got one of those right there, so we don't need to include another one. But do we already have an x minus 3? No, we don't, so I've got to put the x minus 3 here as a third linear factor in that denominator. And then that, everybody, is the LCD that we needed. All right. Now, where are we supposed to go from here? We now need to convert the two existing fractions up there on the top to have this lowest common denominator. So let's take a look. I'm going to go to the first fraction right here, and I'm kind of cramming my work in here, guys. Sorry. Take a look at its denominator, which is right here. Take a look at your LCD, which is right here. What's missing from the LCD from that first denominator? The only factor the first denominator doesn't have is the x minus 3. So we're going to multiply by x minus 3, on both the top and the bottom of a fraction here times the first one. And then as we move to the second fraction, let me give myself a little bit more room right here. Okay, the second fraction. Let's take a look at its denominator, which is right here. What's the only thing missing there in comparison to the LCD? Well, we already have the x plus 3 and the x minus 3. We're missing the x plus 5. So the x plus 5 is going to go on the bottom, and then, of course, on the top here as well. Okay, now it's go time, and this one is more complicated than anything we've done before because when we go to multiply our numerators, we've got to do x minus 3 times 2x minus 1. Binomial times binomial, this is where we're going to have to do FOIL, everybody. So here we go. First product, x times 2x is going to be a 2x squared. Outer product is an x times a negative 1, that's minus x. Inner product is negative 3 times 2, that's a minus 6x. Those combine to make a minus 7x. If you guys haven't started pushing yourself to be able to do FOIL and combining your outer and your inner products in your head, now's the time to start getting yourself used to that. And then your last product, negative 3 times negative 1, is a plus 3. All over my common denominator now, which was an x minus 3, and then an x plus 5, and an x plus 3. Remember, guys, we never have to expand the denominator. Only the numerator. Okay, we have a minus now in between. That'll become important in a second. And now for the second fraction, we have to FOIL the 6x plus 5 times the x plus 5 in the numerator. So first product, 6x times x is 6x squared. Outer product here and here is a 30x. Inner product right there is a 5x. So that's a plus 35x. Got it. And then our last product, positive 5 times positive 5 is a plus, nope, not that, is a plus 25. There we go. And again, the denominator can stay factored. And the order I had this one in doesn't really matter. It was x plus 3, x minus 3, and then we tacked the x plus 5 on the end. All right, guys, so this is messy here. But we're in good shape right now, and I think we're one step away from being done. Okay, the tricky thing now is that this is a subtraction problem, and if you need to take an extra step to write this out, go right ahead. If you can keep track of it mentally, that would be even better. We've got to combine our like terms in the numerator, but we've got to remember that we're distributing a minus sign into that second denominator. So, first term, we're taking a 2x squared minus 6x squared. That is a negative 4x squared. Then linear terms, we've got a minus 7x, and this becomes a minus 35x. That's a minus 42x. Gotcha. And then at the end now, our constants, we've got a positive 3 minus 25. That's a minus 22 all over your common denominator. And the order in which you write these three factors does not matter, guys. X minus 3, x plus 5, and x plus 3. But any order of those three would be okay. The only thing we would have to think about next, everybody, is if that numerator factors at all, and if so, does anything cancel with the denominator? But that is not going to happen, I can tell you right now, in this problem right here. So where we are right now, guys, that is our final answer here for problem number, I don't know what number we're on right here. Okay, so that, everybody, is a pretty good synopsis of all of the different types of problems that we're going to have. And I think this last one we just did was a really good illustration of how complicated these problems can be, where you have to factor your denominators, work hard to build that LCD with everything from the first denominator, and then only the stuff from the second denominator that you didn't already have. We didn't need this x plus 3 again because we already had it from the first one. The conversions involved FOIL on both the first numerator and the second numerator, and then we had to distribute a negative. So, all right, there's a lot going on in 8.5. This is a tough section right here, so I want you guys to dive into your homework right there. I want you to take it seriously, check your answers as you're going along, and let us know when you guys have questions. All right, good luck, everybody.